Hello everyone, and welcome to this PVTech Tech Talk Product Series webinar. I am Mark Osborne, Senior News Editor at PVTech and the moderator for this webinar, which is going to provide an overview of LONGi Solar's recently introduced next generation high performance large area HIMO 5 series module that is specifically designed for utility scale PV power plants. Our guest speaker today is Juan Carlos Gonzalez, the Senior Key Accounts Manager at LONGi Solar Europe. And just before we get started, a quick reminder that we will have time for a Q&A session after Juan Carlos's presentation. And so feel free to post questions throughout this webinar. We'll try and get through, as usual, as many as possible. But we also have some LONGi staff here to help answer questions throughout the webinar. And we'll also, because of this, we have a lot of questions normally. So this helps everybody, I hope. Well, Juan Carlos, if you are ready, let's get started and over to you.
Thanks, Mark, for the introduction. And good afternoon, everyone. Thanks for participating in this webinar organized by PVTech and LONGi. Today, I will introduce the newest LONGi's product we are launching this year for continuing with the LC reduction. Thanks to the impact of this new technology or family of modules in the CapEx and OpEx. So let's move forward. First of all, I will introduce the HIMO 5 series, the portfolio, let's say. And here we can see, we will offer, as always, two solutions based on monofacial and bifacial. And in this case, the layout of the modules will be the typical one based on 72 cells, half-cutted cells, and a new one based on 60 cells, also half-cutted cells, both in monofacial and bifacial. As we can see on the left side, we have the dimensions of the 60 cells based on a power bin of 495 watts. And we can see here the dimensions are a bit more than 2 meters times 1.1 meters. So very close to the standard 72 cells we know till now. Okay. The second option is a larger one based in a power bin of 540 watts. And the dimensions are around 2.2 times 1.1. Okay. This will be valid also for both, as I mentioned before, the dimensions and the power for monofacial and bifacial. Okay. We will see the outstanding design and the reliable in real-world applications through some technology we have integrated in this new module. Okay, the main, let's say, the main change will be is the change on the wafer. We have changed to an M10 wafer, which is a wafer of 182 millimeters side length. Okay, always again, we will cut this cell in two to have a half-cutted cell, since all our portfolio is based on this technology. And here we can see several bullet points or to some points to be highlighted. Okay, as I mentioned, the wafer is a M10. Now we have changed an additional approach is the change of the dopant from boron to gallium in order to reduce the degradation. Okay, this helps us to offer our standard warranty. We'll see later a bit more in detail this feature. All our panels on HIMO 5 series are based in P-type PERC technology. We keep the same approach on the number of busbar compared with the HIMO 4 series. We still keep the 9 busbar in half-cut technology in order to reduce the losses due to the Joule's effect, okay, or the series resistance, and also to reduce the impact of micro cracks thanks to the number of busbar. Okay. We are still keeping the same approach also on the layout of the panel, so keeping 6 rows of cells with on the 72 or on the 66 cells model design. and also including an improved power temperature coefficient of minus 0.35% per degree Celsius, which means we will have a degradation in power, or degradation in power of 3.5% for every 10 degrees Celsius of increase. Okay, all this give us an improved module efficiency over 21% for the module. Okay, and we can see here on the left and on the side of this slide, some parameters for the 72 cells and the 66 cells. Okay, for instance, if we pay attention on the left side, on the 72 cells, we can see the mainstream will be around 540 watts. On the 60 cells on the right side, we can see the power is almost 500 for a reduced dimension of the panel. And the interesting parameter maybe here will be the VOC, the open circuit voltage, which is in both cases below 50 volts, and enable us to make a design of the string with a number of modules in between 28 and 30 modules, depending on which one we are choosing, either the 72 or the 66 cells. Okay. In both cases, the weight is a bit over 30 kilos, which can be managed by 2 people during the construction and the maintenance. And the current, the IMP, so the current for inverter, the one is feeding to the inverter, is around 13 amps, which is in line with the standard market we have available regarding when we talk about the inverters. Okay. One of the key characteristics or features it's helping us to boost the efficiency and the power and the reliability is the smart soldering technology. This helps us to increase the module efficiency by 0.3% compared with conventional multi-busbar products. And this is thanks mainly to, let's say, to 2 main characteristics of the ribbon. One is the triangular section over the cell, which maximizes the use of sunlight, which means we will get a higher reflection on the busbar hitting the cell, so increasing the light hitting the surface of the cell, and therefore increasing the efficiency of this arrangement. And also the flat section in between cells that allows us to reduce the gap between them, which means we can reduce the size of the panel, and therefore we can increase the efficiency of the panel, either for both, for the 72 cells and the 66 cells. Okay. Also, this flat section allows, apart from allowing us to have a higher packing density on the panel, also allows us to reduce the stress on the soldering. Okay. Then increasing the reliability of the panel. As we all know, apart from being the leader and the main driver on the to adapt for the adaptation of the PERC technology, LONGi Solar was also one of the leaders, if not the leader, the main one, pushing for the bifacial technology in the market. Actually, right now, we have already shipped over 5 gigawatts worldwide, and it is verified by pilot projects with third parties and large-scale power plants across the globe. Okay. This HIMO 5 series is optimized mainly from 2 points of view regarding the module size and also from the electrical parameters or all the electrical topics related to the panel. From the module size, the size has been, let's say, designed, or the module has been designed to match with or to be used with the main trackers in the market, either in 1P or 2P setup. Or even, I mean, we can think also to use, for instance, the 66 half-cutted cell in an arrangement of 3H or 4H. Okay, so the dimensions, mechanical dimensions of the panels are fitting the market requirements. From an electrical point of view, it's fully compatible with all the main inverters in the market. And we need here to take into account the additional gain we can get thanks to the albedo. We can see here on the table on the right side that we can, depending on the albedo, also the reflection of the light over the surface below the panels, we can reach an expected gain in between. I mean, the more realistic one will be in between 6 and 15%, depending on the surface, and for sure this will incur in an additional in an increment of the current feed to the inverter that should be and will be, let's say, managed by the main inverters available, as I said before, available in the market without any energy loss or derating done by the inverter due to an extra current being fed to it. Okay. Another important aspect of our portfolio, not only related to the HIMO 5 series, but also to the existing portfolio we have, is the power warranty. We are leaders on, or the best in class, offering the best warranty terms when we talk about degradation. For instance, the degradation for the first year, in both cases, monofacial and bifacial, is warranted equal or below 2%, which here where we include the degradation due to the lighting dust degradation, or LID, known as LID in the market, which is a degradation of any crystalline PV technology that suffers when during the first contact with the light. Okay, and this phenomenon is intrinsic to the photoelectric effect at the end, and specifically to the crystalline technology. Not only that, I mean, we have improved that behavior thanks to, as I mentioned before, to the adoption of gallium as a dopant instead of boron, to reduce the complex between oxygen and boron. So gallium has no this effect, so we can manage or expect a better behavior along the time. Okay. And the key core of this panel, HIMO 5, is the adoption of the M10 wafer size, which is, as I also mentioned before, has a size of 182 millimeters side length. And this has some impact in the overall installation and in general in the panel itself. We'll see if we did analysis on the product benefit on different aspects. For instance, regarding the production, feasibility, and cost, we can offer the cost of this new product based on the M10 wafer is in line with the one we can find it's a market standard cost, even by adopting the technology based on gallium or the smart soldering technology. Okay. From a relative point of view, as I mentioned also before, all is based on the quality of the panel or the cells, and in this case, even on the wafer, and let's say in the whole chain of the panel. We are offering the lower LID in the market right now with the lower linear degradation and the best behavior under mechanical load, especially when we talk about a bifacial module based on a glass solution of 2 millimeters each. Okay, and all this is backed up by the performance warranty we can offer based on the warranty I mentioned before. Additionally, the product has 12-year product warranty, which has been improved recently, like half a year before. Okay. Another important topic is the system compatibility from an electrical point of view with inverters that can manage easily 15 amps, and from a mechanical point of view, compatible both options, the 72 cells and 66 cells, with trackers of 1P or 2P solutions. Okay. From a transport logistics point of view, we have lowered the impact on transportation, since we can increase somehow the density of the container by transporting more power per container, so reducing the cost per watt on the transportation. And from a modern installation point of view, the numbers count, and we can see here the panels is a bit more than 2.5 square meters, and with a weight of a bit more of 30 kilos. That is not difficult for 2 people to manage, install, and handle during construction and operation and maintenance. And let's go to the most important parameter, right? The LCOE, or the cost of electricity. In this case, as mentioned many times in the past, LONGi is targeting to lower the LCOE for all solutions, all our clients, and this is our main goal in order to be competitive in the market. Not only us, but also the designers and installers. Okay, and finally the investors. We can see here a comparison between HIMO 5 series with 72 cells and a standard panel based on a G1 wafer or 158 millimeter wafer of 72 cells. We can see on the left side, HIMO 5 has 540 watts. On the right side, we have this G1 wafer-based module of 410 watts. We can see the differences or the savings in some specific parameters. For instance, to highlight, maybe the labor cost is reduced by 20.6%. The combiner boxes by over 25%. And in overall, we can save on BOS a cost more than $1.2 US per watt. In this case, this is a specific case for an installation in China for a fixed mounting system with 4 modules in landscape. Okay. An additional, a very interesting comparison is this one. In this slide, we can see, like in this case, 6 different module types with different, let's say, wafer sizes. Okay. And we can see, for instance, some key parameters on the left side: the power, the module efficiency, the size of the module, the VOC or open circuit voltage, the typical string length, and the IMP, the current for the maximum power point. Okay. As we can see here, finally, the efficiency is based on the power of the panel and the size of the panel. We can refer to the HIMO 5 on the right side. Both are over 21% of efficiency, compared with the other options that are below or below 20.5%. Okay, even 20 for the G1 wafer, which is the standard one we know from 1-2 years ago. Okay, so based on that, we can see, based on that, and also based on the VOC, which is an important parameter for the design of the installation, we can see, for instance, the typical string length for the HIMO 5 60 cells. We can reach up to 30 modules per string, always depending on the temperature conditions of the site. But on this example, for every panel here shown is for sure the same. So we can see with the HIMO 5 66 cells, we can reach 30 modules per string. Meanwhile, with with 78 half-cutted cells is the one on the second one from the left side, we can reach 26 panels only. So it means that we will have an impact on the overall VOS, because we will need more strings to achieve the same volume installed in installation. Okay, so thanks to HIMO 5, we can reduce the number of strings, the electrical BOS, and also the mechanical BOS. This is shown clearly on the BOS cost. We take as baseline the G1 on the left side, and we can see the cost reduction according to the different options we're going to have in the market. And I mean, just highlighting the option of HIMO 5, we are reaching up to 34% on cost reduction compared with the baseline of 410 watts. Okay, this can give us an idea on the BOS reduction, and therefore on the impact on the LCOE. Okay. And finally, just to summarize all the key points of this product, I mean, there are 5 main points to be highlighted. One of them is as I mentioned also before, it's the reduction on the logistic cost up to 10% compared with mainstream products. Also, regarding the reduction of equipment and material cost and the capacity of the inverters, we can have a reduction on the BOS, electrical BOS and mechanical BOS, thanks to the higher efficiency, higher power per module, and the technology we are offering with HIMO 5. All this is impacting directly on the labor cost. So we are reducing the installation, since we are reducing the number of panels and the volume of the whole BOS. Okay, and finally, thanks to the technology, still based on mono PERC technology, that has one of the best performance under low light conditions, we can increase the power generation together with the low temperature coefficient for the power, which is around it's exactly 0.35% per degree Celsius, and the reliability on bifacial module for power generation. I want to highlight that, as I mentioned before, we have already shipped worldwide 5 gigawatts of bifacial modules. So this is a good track record to enter into this technology, okay, for the ones that has not entered still, okay, or yet. And finally, all this is backed up with our warranty for the product, which is 12 years, and for the power degradation, which has been already explained in a previous slide, that offers the lowest degradation in the market. So that's all from my side. Thank you so much for your attendance. Any question, we'll be happy to reply. Thanks, Mark.
Thank you, Juan Carlos, for your presentation, and much appreciated there. Okay, so we're now ready for the Q&A session. Yes, so just before we get going with that, I just wanted to help out people, just let people know that when the webinar slides actually disappear after the Q&A session, the actual webinar platform is still live. So LONGi staff will be available to answer any more questions if required. So there's no rush to exit the platform when the actual slides finish. We've had this before where people have stayed on and there's lots of questions. And indeed, we have quite a few questions here for you, Juan Carlos. Yeah, I guess a couple of just confirmations here from the presentation. Correct me if I'm wrong, but there isn't because this is a utility scale, it's large area, the smallest of the modules is actually a 66 cell module, and that is, if I remember rightly, you highlighted that was pretty much the same dimensions as the smaller wafer size 72 cell.
Correct. Yeah, this is a new approach that LONGi has made regarding the layout of the panel, just by keeping the same dimensions on the panel as a standard one available in the market in the last year, let's say, or the well-known 72 cells with a G1 wafer size. Keeping the same, more or less the same dimensions, we are boosting the power like more than almost 100 watts per panel. Okay.
Yeah, I think related to that, I guess, is people have asked about is there a plan to have an even larger 78 cell version, but we're getting into size and weight issues there. But the other part of that question from the dimension was just, could you confirm that the bifacial module options are actually, what the sizes are there? I think you were referring there to the fact that they're the same sizes as the standard monofacial.
Correct. On both cases, the 66 cells and 72 cells, both options, monofacial and bifacial, they have the same dimensions. The only main difference will be the shape of the frame. For the bifacial, on the short side is a L shape compared with the standard monofacial with its C shape, but the dimensions are exactly the same.
Okay, maybe another one here I could possibly help out with was about because obviously people are really interested in these larger area sizes, and therefore that's because we've got larger wafer sizes. I know from my work with LONGi in the upstream typically, because people are asking about, say, well, what is the thickness of these type of larger wafers as well? Because obviously people are concerned about weight. But I can tell people that pretty much from the standard or the traditional 156 millimeter squared wafers, they were between 200 millimeters and 180. Anything lower than 180 millimeter thickness causes breakage or higher breakage issues in the cell processing steps. And so with the larger wafer sizes, this is, the 182, this would include the 210. Again, the wafer sizes are not really dictating it. It's actually breakage is the challenge. So it's in the PV technology roadmap that we'll see gradual reductions. So from 180, those reductions, would maybe go down a few percentage points, but also all of the standards are actually being developed in teams for this, so everyone understands the specs. But I thought I'd just ask, put that one in there for you, because I'm very familiar with those developments. Obviously, people are asking about other wafer sizes. People are saying here, is the company planning to switch to, say, the 210 millimeter wafer size? And what happens to the 166 millimeter wafer size? So size modules. I don't know what you want to comment on that one, Juan Carlos.
Yeah, I mean, in LONGi is still keeping the 166 millimeter side length for our HIMO4 series. That this will more maybe suitable for CNI and residential installations. We are still keeping this solution, and together with the 182 of this HIMO5. Regarding the 210, we believe that, you have more risk at the end by using this option, since you need to cut the wafer in 3, which will have more impact, let's say, from a quality point of view. And for the moment, we don't see any advantage of using this kind of size for the moment. Actually, I already mentioned before, on the presentation, all the advantages and why we have chosen the M10 instead of other size, taking into account the logistics, the current, since the IMP or the current produced by the panel, it depends basically on the surface of the cell. So the bigger is the cell, the higher will be the current. So just to be aligned with inverters in the market, this is a good option, we believe.
Okay. We've got what seems to be a very common question amongst this series of product webinars that we've been hosting over the last several months, are the bifacial modules in the HIMO5 series available just in glass, or are they also going to be available with transparent backsheet?
Yeah, in this case, LONGi is keeping the same philosophy by let's say, investing in reliability in a long term. That's why we're keeping, as in our HIMO4 series, in HIMO5 series, we're keeping the same approach by using a glass solution that with 2 millimeters per glass, and always with frame. Just to keep the consistency of the panel, we need to think also on the dimensions of the area we are talking about. Having, for instance, this 2 + 2 millimeters glass on the official panel, we are keeping asymmetrical behavior from a mechanical point of view, and therefore protecting much better the cracks on the cells, the appearance of the cracks on the cells, compared with a solution with just a single glass. Okay, where another reason is about the cost. We think we can see or we can think on the different costs when we talk about 2 + 2 millimeter glass compared with a 3.2 millimeters glass plus a transparent backsheet, for instance. Okay, these are one of the drivers that are keeping us in the same road since the beginning by using glass plus glass.
Okay. I'll try and keep this one short for you, just looking at the time. But obviously, a range of questions here, and I'm just going to tuck them together. There's sort of there's the perception that with higher wattage modules, these larger wafer, larger modules, that the certain costs are actually higher, such as higher, because of the weight and size, things like you need more posts on the racking system. Also, we've had this before about cabling costs because of the strings, string lengths and things like that. How is that actually approached from an LCOE perspective?
Well, actually, as we all know, the main idea is here to increase the power density at a module level in order to reduce, let's say, the number of modules used, and therefore also the land used, basically. And all this will impact directly also on all the electrical connection, cabling, combiner boxes, and also the labor cost. We saw on one of the slides the savings we reached with a HIMO 5 72 cells up to, if I remember well, around more than 30% reduction on cost on the BOS, thanks to the change thanks to this approach compared with a G1 410 watts module. So at the end, by increasing, for sure, we are increasing the area, we are increasing the weight. We are talking about weight per panel of a bit over 30 kilos. The standard ones are around 25, 26 kilos when we talk about bifacial panels, in this case, for example. So for sure, there is an impact from a weight point of view on the structure, but also, but again, we are increasing the power density per string and per tracker. So at the end, we will use less tracker, which means also that reduction on all the electrical circuit on the tracker, the control, the electrical motor used per tracker, and so on. So we are reducing by far the numbers or the cost, the BOS and CAPEX, and this impacts directly on the LCOE. We saw the figures before on one of the latest slides in the presentation.
Got it. Two very quick questions, and hopefully quick answers before we finish. The 21.1% module efficiencies, and as well as when the module will be ready. This is the fact that if you can give us exactly when you're expecting availability of the HIMO 5, and will it come initially with that 21% cell efficiency?
Yeah, this model will be available in both options. 66 and 72 will be already available or in production in October this year, with a capacity of 12 gigawatts. Okay, and regarding the efficiency, I mean, at the end is a matter of, thanks to the smart soldering, for instance, we reduce the dimension of the panels, which is one of the key questions when we calculate we go to calculate the efficiency of the panel. So by increasing the power density, or let's say the power of or efficiency of the cell, we are increasing also and reducing the dimensions of the panel. We are increasing the efficiency of the model. That's why we can achieve these figures of around 21% efficiency. Okay.
Yeah. Right. Well, Juan Carlos, thank you so much for your presentation, and good at answering all of these questions. Once again, we're now, the webinar side of it has finished, but thank you very much, everybody, for being here. Thank you, Juan Carlos, again. But actually, the LONGi people will be here to answer further questions, and I've been seeing that there's more questions coming in than I could even get to in the short time that we had. So to everyone from us at PV Tech and LONGi, thank you very much. Bye-bye.
Thanks, Mark. Bye.